So 5.3 is taking what we've done before, proportions, and tying it into some graphs and some stuff with that, and then we turn you loose and give you a quiz on it later. But proportions, you'll remember, well, I guess going back to the very beginning, we talked about ratios. So you could have like, say a 1 to, and you don't need to write this down, but like a 1 to 10 teacher, we could say, to student ratio. Fair enough? So that was section 1. Hey, look, here's a ratio. If the units are different, if it's not both people, then you'd have a rate. Section 2 is saying, okay, 1 to 10, that ratio is the same as 3 over 30. And you could get that by saying, all right, to get from a 1 to a 3, I multiply by 3. So then I have to multiply by 3 to get the 30 also. Yes? Kind of small, but squeezed in there. So that's a proportion, is the one fraction equals another fraction, or one ratio equals another ratio. So now we're taking section 3, we're doing one more step, we're saying, okay, now what's that going to look like on a graph? So example 1 could or could not be related to Mr. Vanderwall. I know he does like to fish. So if Mr. Vanderwall catches 15 fish per hour, that means he catches 15 fish every how many hours? 1. So we kind of have this ratio like 15 over 1 is like my ratio. I want to take and put it in this data table, but you agree time is the independent, that the number of fish he catches depends on the number of hours he fishes? So I put the time in my top row, where the independent variable usually goes, number of fish in the bottom row. So if he catches 15 fish in 1 hour, I put 15 under the 1 or under the 3? 1. Perfect, because 1 hour he catches 15 fish. If my time is 3 hours, he's going to catch 45. And you could be on track and get that by the same thing we did up here in the upper left by saying, all right, 1 times 3 gets me 3, 15 times 3 gets me 45. Or the other way to do that same, or get that result, would be to say, I always take my time and I multiply it by 15. So 1 times 15 gets me 15. 3 times 15 gets me 45. So a couple different ways to fill the thing in. Good? But if we were to graph this, so I have a proportion. I have 1 over 15 equals 3 over 45. If I were to try to graph that, my time is going to go on the x-axis because it's independent. And I need to get up to 3. So I'm going to do a 0, a 1, a 2, and a 3. And I'm going to try to be as careful as I can on spacing. My number of fish is dependent, so it goes on the y-axis. I need to get up to at least 45. It's going to be a real pain to split up 45. So I'm going to go with 50. And I'm going to put a 50 up here at the top. Or you could start and do 0, 10, 20, 30, 40. I'm going to see how accurate I can be. So I'm going to say 10, 20, 30, 40, 50. So, okay, not great, but I have the origin on there too. Now, when I graph my points, or maybe pause a second, you guys good on the axes? Questions?
We're good.
Okay, looks like people are caught up. So now for this point 115, I start at my origin, I go 1 to the right, and I go up 15. So I have 10, I have 20, I want to be right in the middle of that, and try to be as accurate as you can. But 115 is going to be right about there. Now 345, I start at the origin, I go 3 to the right, and I go up to 45. So I have 40, I have 50, I want to be right in the middle there. So I think it's going to be right about here. And it's tough to do this perfectly without like nice graph paper and so on. But if we could take a line and put a line through those 2 points, at least within the level of accuracy of our notes, I'm hoping, looks like I need to fudge a little bit. When you draw your line, try to get through the origin as well, because that's what should happen if I actually did a good graph. My line connecting those 2 points, because they're a proportion, should also go through the origin.
Do we put arrows on the end?
You could. I don't think it really matters. I'm not going to with mine, but you could put arrows on the ends if you wanted to. The point is, if I have a proportion, and maybe I'll even write it up here below my data table, I have 1 over 15 equals 3 over 45. That's my proportion. It's one ratio equals another. If I go and graph those points with like x being on the top and y being on the bottom, if it's a proportion, The line is going to go through the 2 points and also through the origin. So, and I'm going to try to squeeze that over here on the far right because I want to write some stuff here. I should have left myself a little more room, but I'm going to maybe say below here, so put an arrow and write a graph of a proportion. Should I write ratio equals ratio, or are you guys okay on what a proportion is?
That's good.
Okay. A graph of a proportion will have a line connecting the points also go through the origin. Or maybe just put 0, 0. We'll also go through the point 0, 0. And we'll get to it later. I'm kind of jumping the gun a little bit. But this second graph on the page, is that going to be the graph of a proportion? This one down here? No, because it goes through like 0, 1.5 or something. But we'll get to that soon. Okay, so everybody get that written down? Okay, so give you a second to write it. This next part is the part that's weird. Math usually makes sense, but they're doing something in this next part that a lot of people get wrong because it's counterintuitive. And I'm going to try to explain kind of why it is that way so that people get it right on the test, which is why I'm going to. Up until now, when we've had a fraction like this, it's always 1 divided by 15, right? And 3 divided by 45. A fraction is really just a division problem. Well, we're going to talk about this k. And k stands for a constant. So k, we can't use the letter c because that stands for the speed of light. But k equals the constant for proportions. They use c for the speed of light because it comes from celeritas, which means swift. Okay, the constant for the proportion. Do you agree, if this is my ratio, 1 divided by 15 would make a whole lot of sense? But it's not 1 divided by 15. They do 15 divided by 1. So it's going to be the y value divided by the x value. So the exact opposite of everything we've been teaching you for years. And we'll get into why. It's not just like some evil person trying to make your life miserable. But it's going to be 15 for this one because I do 15 divided by 1 gives me 15. 45 divided by 3 also gives me 15, yes? So you could, for these, you could, if you wanted to, put a little double arrow thing and say k equals 15 over 1 or 15. Or k equals 45 divided by 3 or 15. And see if anybody can figure out why. What does that 15 have to do with this graph over here?
Ooh.
So he's noticing that right here, when you go over for 1, the y value is 15. So that means what about this section right here? Looking for an S word. The slope. That the slope of this blue line is 15 because when it goes over 1, it rises 15. So the rise 15 over the 1 is the slope. The slope is 15. So k then is going to equal the slope of that line. So k equals the slope of a line connecting the points of a proportion. So that's why k is the opposite of what you've been taught. It's y divided by x instead of x divided by y. So while people finish writing that, just want to say one more time, please, please, please remind yourself, remember that k value is messed up. Kind of like we use k for constant, we do the division the wrong way. All right, if I were to take this one here, and I was close, but unfortunately I'm looking at my notes today and seeing that this line doesn't perfectly go through the points. But I'm going to say that that line connects these 2 points for a proportion. I'm at least close. But this first point here, this point right there, is that going to be 2, 1 or 1, 2?
1, 2.
Do you agree that's 1, 2, because it's always over first, then how much you go up or down. So the ratio then is going to be 1 over 2. My second point over here, I'll do this one in purple maybe. This point here is going to be 4, 5. Oh, 4, 4, my bad. So 4, 4. Do you agree that's going to be the ratio of 4 over 4?
1.
So if we're looking at each of these, the constant for this one is 1/2 or 2? Yep.
2.
It's 2. It's 2 over 1, which is 2. The constant for my second point is technically y divided by x, the bottom divided by the top. Either way, though, you get 4 over 4, which is 1. So do you agree I have two different constants? The constant here is 2. Constant here is 1. So are these 2 points, do they form a proportion? No, you can't say 1 over 2 equals 4 over 4, that those are not a proportion. So I have these 2 points here that don't form a proportion. It's not one fraction equals another fraction. They're not equal. The line between them does not go through 0, 0. So the very last line of the notes will say, lines not through 0, 0 do not represent proportions. So do not represent proportions. That's it for today. Any questions we should go over? All right. So the learning targets are there on the bottom. So for tomorrow, just this first assignment.